All right, now that we've given or reviewed the formulas and so forth for slope, let's take a look at some lines and just recall how we know, just from looking at a line, whether or not it has a positive, a negative, or a zero, or an undefined slope. Let's give our lines on this page some names. We're going to call this line here line A, so put an A there. We'll call him line B. We'll call him line C. We'll call him line D, and this one line E. Remember, you can name our lines with little letters. So based on the different lines we have on our coordinate plane, number one says, what does a line with a positive slope look like? So any line that is going up and to the right would have a positive slope. We may not know what that actually is, but we can look at the line and know that if it's going up and to the right, like line A, that means we have a positive slope. Second question, what does a line with a negative slope look like? So in this case, I think of it like falling down a hill. This guy's going down and to the left, sorry, down to the right, down to the right. If we're going down and to the right, then we are effectively, I think of it like rolling down the hill, and we're sad because we might get hurt. So we would have a negative slope in those situations. So lines B and C are negative slopes. And that's helpful to you just as a check as you're coming up with the measures or the values of the slopes. Just looking at the line ideally will tell you if you should have been positive or negative, and if you're the opposite, you need to reconsider what you did. All right, our zero slope, that's anybody who is a horizontal line. In this case, line E is our zero slope, line E. And then our undefined slope would be line D, the guy going vertically. So line D. Okay, just a little recall. So given that, here in geometry, we're very interested in slope relationships as they relate to perpendicular and parallel lines. So fill in this information on your sheet. It says how do we know if two lines are parallel? If two lines have the same slope, then they are parallel. Please write the word same into that location. And let's take a look back at our picture to determine where we might have a couple of parallel lines. Just looking at the picture, it looks like B and C would be potentially parallel. So we're going to assess their slopes. We're going to look at what the measures of the slopes are in order to see if they are parallel. And if the slopes are equal, meaning they're the same, then we can say for sure that the lines are parallel. So over here on the margin, I'm just going to write, let's assume lines C and B are the two we're looking at. Okay, so we're going to do this two different ways. First, we're going to look at line C, and we're going to use the slope formula for that. So remember, that would be m is equal to y minus y over x minus x. X, that's not a negative x, that's just an x. Let me fix that. X minus x. Again, I like to put all this directly in my calculator, hit math, enter, enter, and I'll get what I'm looking for. But we need to find some points to determine what we're going to put in here, right? We need an x and a y and an x and a y. So I'm going to go to my graph and let's focus on maybe this point and then maybe this point, where we know for sure we have points that are sitting, we call those an integral coordinate because they're living right on a whole number. So those 2 points we have are 1, 2, 3, 4, 5, 6, 7, 8. Looks like 8 on the x-axis for this guy, and 1, 2, 3, 4, 5, 6 on the y-axis for this particular point. This guy up here, we've got 1, 2, 3, 4 on the x-axis, and 1, 2, 3, 4, 5, 6, 7, 8 on the y-axis. All right, so we have 2 points that we can now input into our slope formula. I'm going to do that down here, back down on our equation. Y minus y. So I'm going to start with, let me go back to my points. We'll call this x and y, so make sure I remember who's x and who's y. So my first set of points, I've got an 8 for my y, minus, it looks like a 6 for my y on the second. And let's leave that blue. All right. And we've got, let's see here, a 4 for our x, and then a 8 for the x on the second one. Keep in mind, a lot of times you do like x1 or y1, x1, and y2, x2. As long as we stack them correctly, we got what we're looking for. So I'm going to put this directly into my calculator, and I'm going to just hit math, enter, enter, so that I don't have to worry about coming up with who's negative and who's positive. So it'll be parentheses 8 minus 6, close parentheses, division sign, open parentheses 4 minus 8, close parentheses, enter, and then math, enter, enter. And what I get as a fraction, remember we talk about slope, we use it in a fractional form. It turns into -1/2. So that is the slope of line C using the formula. Now, I could also use the rise over run process. So for line B, we're going to just do rise over run. And when I say that, I'm going to focus on 2 points. We'll use this point right here. That's definitely hitting a whole number. And then we'll use this point on B. So if I were to kind of make a little box, from this point to here, I rose up 1. So my rise, excuse me, I'm losing some space. My rise would be +1. And my run is I'm going to the left, right? We're going -2. So I do a -2 for my run. And when I do that in my calculator, maybe 1 divided by -2, I'm going to come up with a -1/2. So what we've proven is that the slopes of those two lines are the same, and because they are the same, we would say, yes, those lines are parallel. That's the way this is going to play out. For perpendicular, what we have is what we call a opposite reciprocal of each other. So if we know that two slopes are opposite reciprocals, then they are perpendicular. Make sure you write the terms opposite reciprocal down. Now, what does the term opposite and what does the term reciprocal mean? Because those are terms I know you've heard somewhere in your math life, but let's review. The term opposite means we are going to change the sign. So write the term change sign underneath, if you have room. And the term reciprocal means we're going to flip that sucker. Meaning whatever that fraction is, if it started out as 3/4, we're going to turn it into 4/3. All right, so let's take a look at how this plays out. We've got a couple of lines on our picture. To me, it looks like lines A and B are perpendicular. So I'm going to put over here lines A and B. And we're going to confirm that's the case. Now, we've already decided what the slope of line B is. So I'm going to put here line B's slope is m is equal to -1/2. Now we need to determine what line A's slope is. So line A, and again, I'm going to use the rise over run process because it's a little easier than trying to dig through the formula. So I'm going to flip back up here a little bit. I have a point that I'm going to use here, and then I have another nice point here that are hitting right on a whole number. So again, I'm going to do rise over run. So from this point, I'm going to walk myself up to the point where I'm hitting, or the location on the y-axis where it's going to stop. So I went up 2. So that's my rise. Okay, so I'm going to just put over here +2. And then my run is looking like I'm going +1. So +1. Okay, so we have found that our slope for line A, we'll say m, is equal to 2. And now I have to ask myself, are these two slopes opposite reciprocal? If I were to compare the two slopes, right, this first one for line B was -1/2, and compare that to the slope of line A, which is 2, are they opposite reciprocals? Well, we know they're opposites because we had a negative here and we have no negative here, which means we have a positive. So we definitely have an opposite situation. Are they reciprocals? If I were to put a 1 underneath my 2, have I then flipped the fraction, meaning what was 1/2 turns into 2/1. And so because these are living in different signs and a flipped situation, these are perpendicular. Remember our sign for perpendicular. These lines are perpendicular. All right. So let's go to the back of the page. And we have a couple of different examples to consider. It says find the slope of a line that passes through points E and F, and then what is the slope of the line parallel to that line, and what is the slope of the line perpendicular to the line. So what we're going to do, I'm going to do it here in the margin. I'm going to do m is equal to y minus y over x minus x. And I'm going to walk over to my points to make sure I know who's who. So here's x and y, and here's x and y. And then I'm going to just input that information, and I want to use my calculator to the best of my ability here. I've got y, which is -2, minus a -4, close parentheses, divided by x, which is -1, minus a -6, close parentheses. Okay. Make sure you have that written down, and then in your calculator, please input that information and pause the video and see if you get the same thing as I do. All right, so you should have gotten the fact that the slope of that line is going to be 2/5. Number 2 says, what is the slope of the line parallel? Well, remember, for parallel lines, we have the same slope. So if I were to say, what is the slope of a line parallel to a line that passes through the points E and F, given the points, then I would say that the slope of that parallel line would be the same or just straight up 2/5. We do no math work there. We just have to understand the concept. Number 3 says, what is the slope of the line perpendicular to that line? So remember here, we need to flip it and change the sign, also known as the opposite reciprocal. So what I started with, which was 2/5, I have to flip him. All right, that's a little arrow just to show you what I'm about to do. I'm going to make it 5/2. He started positive, so I need to make him negative. So the slope of that perpendicular line would be -5/2. So slope of the parallel line is here, same as the one I came up with. Slope of the perpendicular line is here, opposite reciprocals. Go ahead and pause the video if you need to finish writing all that information in. All right, so here's a couple more examples. The question says, how can we determine if two lines are parallel, perpendicular, or neither using slope-intercept form? So now we're digging ourselves deep back into algebra. Our goal here is to get the equations given into the y equals mx plus b format. And we have, in example number 1, 2 equations given to us. I'm going to call this first one A and the second one B, just to kind of keep my head straight. And again, the goal is to get it into y equals mx plus b. So for A, I'm going to rewrite the original equation, 3y equals 2x plus 8. So our goal is to get the y over here by himself. And the first thing I need to do to make that happen is divide both sides by 3. So the 3's cancel out on this side. I'm left with a y. I'm going to take this 3, distribute it here, and distribute it here, meaning he's going to end up as 2/3. I can stick him underneath the 2x, and then I can stick him underneath the 8. Now that I have it in the form I need, my slope pops out, and he's right here at 2/3. That's my m. For my second equation, which is b, or I'm calling it b, y is equal to 3/2 x plus 3. Well, I don't have to do anything to this because it's already in the y equals mx plus b form. So I'm comparing the two slopes. So I'm going to do that over here in the margin. I've got 2/3 versus 3/2. The question is, are they parallel, perpendicular, or neither using slope-intercept form? Now, I can see that the guys have flipped, right? I have a 2/3 and now a 3/2. But the only way for this to show that it's perpendicular would mean I would need a sign change, meaning one would need to be positive, one would need to be negative. That is not happening here. So my answer to this question would be neither. All right. What I'd like you to do now is go ahead and walk through number 2. You're going to, let's call, again, the first equation A, the second equation B. You want to get the two equations, if not already, into the y equals mx plus b format. Here's y equals mx plus b again. And that way you can determine the slope and you can figure out whether or not they're perpendicular or parallel. Please pause the video and walk yourself through that example and then check your work. All right, and you should have gotten that these two lines happen to be perpendicular to each other. You can see here the slope of line A is 4. That one's simple because it's already in the right format. For B, we did have to do a little bit of work. and here's some algebra, and here's some algebra, and then I turn it around here at the end. I turn into a slope of a negative 1/4. And since we have effectively flipped 4, right, 4 and 1/4 are flipped, and we have changed the sign, we have ourselves perpendicular slopes. All right, last example. How do I graph a line using only the slope and 1 point? So this is just, again, going back to algebra. I know that the line's going through negative 1, 3. So I'm going to plot that point. Negative 1, 1, 2, 3. Go ahead and plot that point. And they tell me the slope is negative 2. So let's look at that as in rise over run. So we could say rise would be negative 2, and the run we can put a 1 underneath that because we can always stick a 1 underneath whatever number. So I'm going to use rise over run as my tool. Whoops. And then I'm going to just walk from the point they give me up or over or down and whatever I've got to do. So here I'm actually going down 2, 1, 2, and then I'm walking over positive 1 to find another point. I can go down 2 and then 1 over to come up with another point on the line. So with your straight edge, go ahead and let's draw that line. I'll do my best drawing as well. All right. Number 2, it says, how do I graph the line perpendicular to another line? Well, we're going to use the same, we're going to use this line, and we're going to use the fact that we need a perpendicular slope. Let me erase this M. The goal here is to flip and change sign. So my original M was negative 2. My perpendicular is going to be a flip, so it's going to be a 1/2, and it's going to be positive. So I'm going to go back to the original point, which was at negative 1, 3, this guy right here. Now I changed it to purple. And I'm going to use my new slope to find some points. Remember, rise over run. So from this point, I'm going to go up 1 and over 2. And then I've got a nice point. So up 1, 1, 2, there's a point, and so on. I've got enough points for sure to fill this in, so we're going to draw it. And our goal at this point would be to have these two lines forming a right angle, because that's what we like with perpendicular lines. Let me see if I can make that happen with this cute little square. We can check our work. Line them up. Looking pretty close. My little hand drawing. Not too bad.